So I want to say a big welcome to all of you here today. We want to look at one of the fundamentals of finance, which is the time value of money. The time value of money is an important topic. And I'm going to start that by asking you some things using this illustration. So would you rather receive 100,000 today or 100,000 next year? Which one will you take? And Linda, can you please put it in the page and then tell all of them that we are live?
Okay, sir.
So I need your answer now. Which one will you go for? Joseph? Richmond?
Yes, please, after going through the notes, I'll rather receive 10,000, 100,000 today.
Right.
According to, there's an ideology about time value of money, which says that the 1 cedi you hold today worth more than the same 1 cedi received in the future. So by that ideology, I'll go for the 100,000 today.
Why? Why will you do it today?
Because of time value of money.
Yeah, what do you mean by because of that?
Because I can invest the 100,000. I can invest the 100,000 now and then make some profit on it, as compared to receiving that 100,000 in the future.
Okay, good. I hope the rest of you understand the principles there. So you take the 100,000 today because you can put it in an interest-bearing asset. And by 1 year, it would have given you an interest together with the 100,000. Now, you said that by going through the notes, you were able to get that picture. Okay. And that principle is because money has value over time. That's the first principle. Money has value over time. So $1 today is worth more than $1 tomorrow because you can get an interest by tomorrow on $1 today. But let me ask you this. Would you rather take $100,000 today or $110,000 in a year's time? Which one will you go for?
100,000 today.
Why?
Because it's ready now, and probably in a year's time, $110,000 will be worth less than it is today.
Did you use the word probably?
Yes, please.
Yeah, probably is not something that we talk about. So what does it depend on?
Probably inflation. Inflation, sorry, not probably inflation.
Not necessarily. What does it depend on? Oh, you know, the $110,000 in a year's time is better. But what does it depend on? It depends on the interest rate. Do you agree with that?
Okay, I didn't know the 110 that we are talking about would have been in a bank or in a situation where would have been gaining interest.
You didn't know. But well, that 110,000, you're getting it in a year's time.
Okay.
The $100,000 is today. So if you say that the only reason why you would have taken it was because you're going to invest it and then you get an interest, isn't it? That is why you would take the 100,000 in the previous question. That's why you normally would go for the 100,000. But what if the interest rate means that you're not going to get anything by a year, then it means that taking the 100,000 today is not going to make any difference. So it depends on the interest rate. Okay. It depends on the interest rate, and the interest rate matters here. So all of these are what we call the time value of money. It's a very powerful concept, okay, which says that the sum of money is worth more now than the sum of money will be tomorrow due to its potential, opportunity cost, inflation, risks, and so many things. Sometimes some people call it the present discounted value of an item. So what is the formula for finding the present value of an item? Well, if this is your first time you are learning this, and I want to believe this is not, but if it is, the present value of anything, any item, is the future value divided by or multiplied by the discount rate, where the discount rate is 1 over 1 plus the interest rate raised to the power t. Now remember that t is the time period. Sometimes they use I for it. But what is the future value here? So before you can get a present value of an item, you got to know the future value of that item. Because once you know the future value and you multiply that whole thing by the discount rate, or you divide the future value by 1 plus the interest rate, given the compounding, you can now find the present value. So when you want to find the present value, you want to know the value of something in the future now. And the future cash flows of all of those items are discounted at the present discount rate. Now watch it. There are two different formulae that I give you here for the future value. The future value of an item, as you can see here, in fact, the same principle, the same element that you see here. But you can see that I've brought a frequency of compounding in a year. So without considering the frequency of compounding, the future value is just the present value multiplied by 1 plus the interest rate raised to the power t. But if the frequency of compounding within a year matter, then you have n being the frequency of compounding multiplied by the t. If it is already a year, then it doesn't matter. Then the n doesn't matter. But if the frequency of compounding changes, then n matters here. The frequency of compounding is very, very important anytime you are analyzing the present or the future value of an item. Let's take a couple of examples of the frequency of compounding. You can have a quarterly compounding interest rate, which means that the frequency of compounding is 4. You can have monthly compounding interest rate, which means the frequency of compounding is 12 because there are 12 months in a year. There are how many years in a year? There is only 1 year in a year. So if there is only 1 year in a year, you will now have t multiplying n, which is 1 multiplying 1. And so the frequency of compounding becomes the year itself. Half yearly compounding means that you're going to multiply the t by 2. But I want you to understand that the frequency of compounding matters in knowing how much you are going to actually get from either the present value or the future value. How many times the interest is compounding within a year under different compounding frequencies. The frequency of compounding will affect how much interest will accumulate over time. We're going to take a couple of examples. And to do that, We're going to do it in Python. So I want you to open your Python already from the document that I gave you. We're going to use a package in Python, which is known as NumPy. Let me open that, and then you follow me along with that. I'll be using that together with, and I'll be asking you a lot of questions, so please pay attention as you go. All right, now before we start the time value of money in Python, there are some few things you want to know. Sometimes when you're doing Python here, as you can see here, what you can do is that if you want a package, you can force install a package. You can use the PIP, the pip function, to, force install a package into the library if it doesn't come in easily. So on your package, have I given you this command? Have I given you this command in the document I gave you?
Yes, please.
Yes,
Good.
sir.
Yes, please.
Run that. Okay, if you've opened it, run that. Okay. Now I'm running that, so you can see that you have the star showing that this is running. So I'm just, force installing the package. You see, it says that you may need to restart the kernel to use the updated package. So sometimes it is like that. So let's restart the kernel. All right. So now you can use this command to import the NumPy. The NumPy _financial NPF is a Python package. It's a Python statement that will import the NumPy financial library into the Python. And this library extends the NumPy, that gives you the financial functions for calculating all the things we are going to be calculating. Calculating anything related to present and future values, net present value, internal rate of return, profitability, and so many things. All the payment calculations, loan amortizations, everything. So this is the function that we are going to use. So run that package, okay, which is this one. Once that is already run, which I have done mine, and I want to believe that you've done yours, because I'll be letting you do some things here for me. You can now run this command. dir will give you all the properties and methods of that specified object without the values. So if you run this command, it will give you all the properties of that NPF, the NumPy financials. The NumPy financial has got features like cached, DOC, file loader, packages, financials. It gives the future value, okay, the IMPT, the internal rate, the modified internal rate, NPER, NPV, PMT, all the necessary things you can calculate. It will give you all. This will tell you what you will be using later on. If you want some help on this function, all you got to do is to run the help on a particular thing. So suppose you are running future value. And a financial analyst use this a lot because you don't need the financial analyst to do this for you. Once you have this, it makes life easier. You can quickly run any customer that comes to you in any financial institution or even for yourself. You'll be able to calculate all of these financial instruments, the returns on all of them. So if you want any help, you just run this help for future value, and then you'll get all the necessary help related to future value. So this will give you how to calculate the future value. It tells you that if you want to calculate the future value, You got to know the rate, which is interest rate. You got to know the number of periods. You got to know the payment accumulation. You got to know the present value. And then you got to know the duration. Each one has been given. Okay, so it tells you that the present value is PV. The interest rate is the rate compounded once per period of which they are. Okay, the NPER is the total amount. The fixed payment is the PMT paid either at the beginning. Okay, that's where the N is. Okay, the when will have the beginning being 1 or the end being 0 for each period. And when you run this analysis, the return is going to give you the value at the end of the period. So it gives you the help related to that. Now remember that this help is for future value. And you can run the second one also for present value. So when you run this, you'll also get the help associated with the present value. For you to know the present value, set the future value rather to 0. And every other thing remains the same. We're going to do a couple of calculations with it. So let's start with the first example here. Compute the present value of $100 received 3 years from now at a 1% inflation rate. We are going to call the NumPy function and pass in the discount rate, the number of periods, and then the future. Now, I gave you this trial run, but I didn't give you the command, did I? Did I give you the command?
No, please, you did
Good.
not.
So what I want you to do is to run it, type it and run it, and let me know what you got. Of course, the first one is going to be a little bit complex for you. So what I want you to do to be able to run this thing well is use the import NumPy function, financial. Okay. So you're going to use, and I want it to be typing because I want you to tell me your result. So use import NumPy underscore financial as NPF. So you type that import space NumPy underscore financial. You type the full name, NumPy underscore financial as NPF. As NPF. That is the first command. I want you to run that. And what are we calculating here? We are calculating the present value of $100 received 3 years from now. So if I get $100 received 3 years from now at a rate of 1%, the word is interest rate. I don't know why I wrote the inflation rate. It's the interest rate. How would you calculate the present value? How will you calculate the present value? So the present value will be equal to, I'm just showing you how you calculate the present value. You bring the NPF dot PV because we are calculating the present value. Now what I wrote on the left, you can use any other thing. Then into brackets, remember the definition of the present value in this command. If you can remember, the command says that if you have a rate, so you type rate. And then the interest rate was 1%. So you do 0.01. Then you do comma. I want you to put these things in while I'm talking with you. You see, if you are doing it individually, you can calculate this by hand, but you're going to do a lot of them. So I want to show you how you do that, using the software so that you can always use the software for it. After the comma, then you do your number of periods, which is NPER. And in this case, the number of periods was 3 years. So NPER will be 3. Then you write your PMT or your payment. Okay. Whether these payments are every single year, but in this case, there was no payment that you were given. There were no regular payments you were given. So PMT will be equal to 0 because there was no payment. And then you bring your comma and then your FV, which is the future value. We know the future value from the question to be 100. So you write 100. You do a comma, then you go to when. When is equal to, we are using end because there was no beginning of the when. So you just type end. So you do double, because it is not a numerical variable, you do END with the apostrophe for the left and right side. And then after that, you can close your bracket. So this is your second line of command. So you run this. But after running it, okay, so I want to see which of you have run it first of all.
Doc, I've run it.
Okay, what did you get?
It didn't bring any results.
Good. So if you want the results, what would you normally have done?
Print PV.
Okay, do that and then you see. What did you get? What did you get? Is it taking that long for you to do your print PV that you said?
Hello.
Yes, go ahead.
Yeah, please. I had 97.06.
Now, what did you type? That's what I'm interested in.
Okay. Okay.
You
So,
type before you do that.
I followed the lecture note, so
Okay, so you are copying.
Doc,
no,
Doc,
no, no.
I got negative 97.05.
Exactly.
Nine.
Is that what, who is the other guy? The one who is copying from the lectures. So you are not understanding, you're only copying, right?
No, I've read the lecture note. So I'm just doing the right thing, that's why. Even though I'm following what you are saying, I'm just doing the right thing. I added negative to the PV.
Why?
To get positive.
Why?
Because you have said it in the lecture note.
Yeah, but why? Not because I've shown. Why? So you're copying without knowing why? Is that what you're saying?
No. You said that if you don't add negative to the PV, it will give you a negative answer. That's what you said in the lecture note.
Why? Why?
Okay, so for the why, I don't know.
So you are following the lecture notes and that's it deliberately without not questioning. You should question the why. I shouldn't ask you the why. You should say that I read the lecture notes and you're supposed to add negative.
Okay, sorry.
So,
Doc, please, I'm having a little problem here. After the import NumPy financials and NPF, I had an error for that aspect.
Well, what error did you get?
You said model not found error.
Check the spelling. Check the import. You wrote NumPy _ financials.
Yes, please.
Check whether it was financial or it was financials you wrote or there was underscore. I can't see your screen, unfortunately, to detect the problem.
It was financial without S.
Okay. And just that one gave you the error, or after you've written the formula itself?
No, just that one gave me the error.
Just the import gave you the error?
Yes, please.
Oh,
Import
yours,
underscore financial.
yours is very quick. Yours is very, very quick. So the import alone has given you an error. Check the spelling again.
Okay, sir.
Was the import written in green on your screen?
Yes, please.
Was there a space?
Yes.
Yeah, what exactly does it say?
Is there no model named NumPy Financial?
Did you do the pip install?
Yes, please.
And then what did that pip install say?
He said you may need to restart the kernel to use updated packages. And the error said invalid requirement, hashtag there.
Yeah.
The same as, yes, please, like seen on your screen.
And did you restart?
Yes, I restarted the kernel.
And then you run the import, you run this one, and then you got that error.
Yes, please.
There's a problem there. It can't be yes, please. You have to check carefully.
Okay.
There is something that, are you able to share your screen?
Unless you give me the permission.
The rest of you, did you all do what she did? The rest of you,
Yes,
did you
please.
do what she did?
Doc,
Yes,
yes, please. I did.
You all did a pip install. Did you have that error?
So for me, initially I had the error, but I restarted the kernel and then reran it, and it was installed successfully.
So why is she saying that she restarted? Are you sure you restarted?
Yes, sir.
Fancy,
Should I show my screen?
Yeah, I asked you to share your screen. You said that you cannot share.
Oh, I can. I'm coming.
Share your screen and let's see.
Okay.
You can always use round. You can round it to a particular decimal so that you always don't have too many numbers following it. Okay. So you can do that. So do negative PV. After that, we are going to do a rounding.
Okay.
And the question I was asking your colleague, so this one is giving you that, but you can do round after the bracket, after the first bracket, the left one, type round, R rounding, not capital letters, my darling.
Okay.
Then bring a bracket again, and then close that PV bracket. So the bracket must be closed twice. Okay, go leftward. Don't run.
Okay.
Bring a comma. No. Go leftward. Yes, bring a comma and then set the number of the rounding, whether it's 2 decimals, so you can write 2. And then you can now run it. Control Enter. Get used to Control Enter instead of always going to click. So this give you the rounding of your, oh, no. The 2 must be inside the PV.
Okay, sir.
Not the second one. Close. The 2 must be, it should be PV, comma 2. Yes.
Okay, sir.
So this helps you to always know. Okay, so that goes back to one of you who said he doesn't know why we are using the minus, even though he saw the minus. So who can tell me why you have to use the minus? Why do you have to attach the minus to the PV in order to get the answer to be positive? Why?
Hello, Doc.
Yes.
I think it's because we are discounting.
Exactly. It's because the money we are getting is the present. The money that we are getting is present. So we want a value that is positive. It's already lower than the 100. This money of 97.06, we are already, is a discounted value. And in the future, is going to be 100. And we want to know its value today. So the negative, simply means that we are spending. Spending here means it is going away. So we are spending cash. Not that we are receiving cash. We are spending the 95.06 today so that we'll get it 100 tomorrow. So we are only if you don't bring the minus PV, the value will be negative, which wouldn't make any difference too, because you just have to know it in your mind that it is negative value. So what it means is that if you want to get $100, in 3 years' time at an interest rate of 1%, then you have to spend $95.06. All right. So I want you all now to use that principle to work for trial number 2. Given what you've just done, everybody work out the trial number 2 and tell me your answer. Now, one thing you can simply do is that you can copy all that you've done, and then you can edit. Okay. You just copy all that you've done, and then you can edit it. So who is done? Whoever is able to calculate, let me know. So this one is, what is the future value? If you check it, it's not asking you for the present value. It's asking you for the future value of $100 investment if the interest is compounded yearly at an interest rate of 5% for 3 years. Now remember, I gave you the up there, I gave you, if you want to know how to calculate present value, this was a help. And I also gave you, if you want to calculate the future value, this was a help. And if you can look at the future value, this is the formula. So you are just trying to write this formula up here for all of them. The only difference between this and the one before is that F20 starts. Instead of the previous one, PV was starting. So here, F20 is the one that is starting. If you check the one we just solved here, okay, you will notice that we wrote PV for this. Okay, so you have NPF.PV. The interest rate was that, so that would change. The number of period is 3. This is still 3. The PMT, the payment is 0, okay, which is still going to be that. Okay. The future value here will not be used. What will be there will be the present value, because remember, it says that what is the future value of $100 investment? So the $100 investment is the present value we have now. So on the basis of that $100, how will you calculate the future value of that $100? Now remember that because the value here is not going to be FV, but it's rather going to be PV, and PV is normally negated. So you can do a negation, you can do a negative attached to it. Because remember, the PV is always negated. If you look at the previous one, we negated the PV. So you can negate this one so that the future value will be positive. Who has still been able to do it?
Okay, I have.
Okay, what did you get?
115.76.
Without, I think that one is not in your notes, right? Oh, it's
I'm not even check the notes. I'm not even looking at the notes.
Okay. If you're not looking, that's okay. That's okay. I just want to be sure that you are not copying for copying sake, but you are learning. That's all. That's
Yeah,
all.
please, I've done it. I've also done it.
Okay. Who are the others? Have they done it? Who's the other person? Rabna, are you here?
Hello, sir. Yes, please, I'm
Do you
here.
have your laptop open? Are you actually doing it with us?
Yes, please, I
What
am.
did you get? Linda, what did you get?
127.63?
Richmond, what did you get?
115.76.
You see, you say 127, he's saying 115. So someone is
Yeah.
doing wrong. Okay. So now, when you check this, you should get 115. Okay. You should get 115. But why is that so? And here's it. I told you it's positive here. And the reason is because the present value, check it and correct your mistakes now. The present value is 100. And I told you to negate the 100. The negation simply means that you are spending that one today. Okay. And in the future, you're going to get $115.76. $115.76. Now, watch it carefully. You see that when I was printing the future value, I did not add negative to it because it is going to be received. You are not spending, you are rather receiving it. And so that is why that one is positive, unlike the previous one where you negated it. The one who got to the 1112, have you corrected it?
Yes, sir. I've corrected it. I made a mistake with the n pair value. I went to enter the 5 instead of the 3. So I've corrected it now.
Okay. All right. So you've gotten the picture now. This is a warm-up. This is just a warm-up. If you have been timed, suppose I time you in Sakai, and then I give you a series of questions like that, and you got just 10 minutes to answer all of them, your brain must work sharp to be able to know what the question is requiring you to calculate, whether it's the present or future value. And then here, we've not even brought checks yet. Here you can see that there is no payment that is being made every single year. So you can see that the payment section is 0 for both of them. The payment section is 0 because we have not introduced, apart from what you are spending now, we don't know what you are spending every other time. We've not brought all of those things. So if you have a question here, quickly let me know before we proceed. Any questions so far? Anything that is not clear? Okay, good. Now let's go to the next one. The next one is an example 1. Okay, now we are getting into the bit of the real deal. Example 1. In this example 1, you are being asked, what is the present value of the deposit? If you expect to earn 5,000 lump sum payment in 5 years' time, if the discount rate is 8.25%, I want you to work this using the same principle. And I want to believe that this one too, you didn't have any solution. So I want you to work it and let me know what you had. Who is done?
Okay, Doc.
What did you get? You have done your coding already in Python, so you are just showing me your results. Yeah, what did you get?
Please, I had 3,363.8.
Okay, we'll come and check. Who else is done? Who else is done? Who was speaking, by the way?
Richmond.
Which one? Seth, are you with us?
Yes, sir. Yes, sir. Please, I'm here, sir.
You have not, I think you are not with us. You have not really spoken today.
Yes, sir.
I know my people. I know my people are hiding behind the scenes. There are two possibilities. You are not ready. You are doing something. You've not even turned on your laptop, or you have turned on, or you just turned on. Which one?
No, sir. I'm actually following every bit of what we are doing and typing as well, sir.
But you're not talking and giving me your answers yet.
Yes, sir. That's true, sir.
So what did you get?
But my attention is here, sir.
What did you get for this?
Yes, sir. I'm coding still, sir.
Elvis Goku. Who is Elvis?
Yeah, I'm not using my laptop now. I came from church. This is someone else's.
Yeah, you are one of those people who are actually not supposed to be around here. The people who insult our intelligence.
Also, I do not insult you.
How about you? Don't laugh. I'll penalize you. Don't laugh. Don't even smell laugh. Because this is serious. All right, what did you get?
Please 3363.8.
Joseph, what did you get?
Doc, please, I got 3363.8.
Linda, what did you get?
Doc, please, I got 3,363.8.
So you all know what you're doing.
Yes, sir.
All right. Now there's something that you should learn. You should not normally give your answers in single values like this. Okay. It's important that sometimes you write your answer in style. Okay, so here you can see that I've written that you should print the statement that says the investment is worth that. Okay, so the investment is worth $3,363.8 in today's dollars. So I put it in a sentence. So that is one way you can showcase your result. I would encourage you to edit quickly what you wrote to this format. This is a very nice way to speak out because, like I told you, Python is also a speech giving, software. It's a Word document sort of. So when you do it like this, it doesn't make the answers stand on their own just like that, like this one is. But to do that, you need to bring the double apostrophe. Remember to space. You can see that there's a space after the word. And then you are now adding a string variable, plus a string variable which is rounded. And because it's a present value, again, you introduce your minus, and then you add the other sentence after you have spaced the whole thing. If you don't bring the space, the whole thing, the two words will be put together. Okay. So that is the answer to the first one. Most of you have gotten the example one. Let's go to the example two. The example two is a little bit trickier. It's a bit tricky than the example one. Now here, I'm going to just remove the dollar symbol here so that the words are not italicized. I have more dollars. So all right, so what is the present value? Is a question. What is the present value? That is, what is the initial investment of an investment that leads to total of $15,692.93 after 10 years of saving. After 10 years of saving $100 every month. Assume the interest rate is 5% every year, compounded monthly. Now, before you start running and doing it, I want us to discuss how What is this question actually? What is the difference between this question and the previous one so far? Let me start with Richmond. What is the difference between this question and the previous one so far?
Please, I'm still analyzing the question.
Oh, you are analyzing. Normally, you are the first to finish. Wow. Then let's see who else is analyzing. How is this question different from the previous one? Set. I could easily give all of you the answer.
I think here I'm seeing that there's a monthly compounding interest, where previously we were dealing with annual interest calculation.
Good. Very good. That's the first observation here. You have a monthly compounding. Okay, when the previous one, it was annual compounded, but it didn't say compounded, but I mean, it did not use the word compounded monthly or compounded, what do you call it? Compounded 12 monthly. It just says compounded annually. Okay, so that is the first difference. The compounding is monthly compounded. What is the next thing?
Doc.
Yes.
You can also see that there is a series of payments, a fixed payment, which is the 100 cedis every month.
Good. So in addition to the usual one, the payment that was zero, the fixed payment that was zero, in this question, you are told that they are saving $100 every month. So there's a fixed payment every month. Okay. So that is another observation there. What else? Anything else? I think it's basically it. These are the things. So a couple of things will change. You are still going to use the present value because the question is actually asking you to calculate present value. So you're not going to use a feature value formula. So you're still going to use this formula, this present value formula. But a few things will have to change. Now, the interest rate is still 5%, like, from the couple of trial 2. The interest rate is still 5%. But this time, because it's compounded monthly, what do? So if you look at NPR, okay, if you look at the interest rate, which in this case is 5%, 5% is 0.05. What will you do with that 0.05? Because remember, it is compounded monthly, not compounded annually. What do you think you would do with that? Would you add, subtract, multiply, or divide?
Yes, you divide.
You divide by what?
12.
By 12. Good. So you know that your rate is going to be divided by 12. So whatever rate that you write, you divide it by 12. Okay. And you know that your payment is going to be what? Previously it was 0. Now it's going to be what?
100.
Good. Is it positive 100 or negative 100? And whatever you say, I'll ask you why, so don't worry. So this is what must go through your mind when the time is going, when the time is running. Is it positive 100 or negative 100?
Please, I think it should be negative 100.
Why?
Because he's saving that 100 every month.
Good. So he's spending, it is going away. Because it's going away, it's leaving you, it's not coming, but it's leaving you. That is why it is a negative value. So the payment, the PMT here is going to change to a negative 100. But there's something else. There's something else. The NPER, the number of periods, what was it? How many years was that?
10 years.
10 years.
So it's supposed to be what? Because remember, everything now must not be in years anymore. They must all be in what?
Months.
Months.
Months. So now, what do we do with that number of periods? Do we subtract, add, multiply, or divide?
We
Multiply.
multiply.
We multiply.
We multiply. So watch it carefully. Whilst we are dividing it by 12 with the interest rate, we are multiplying it by 12 with the number of periods. Now, I want you to work your work and tell me what is the present value of this scenario. Oh, and by the way, do your write-up by printing the results, in a very nice sentence like this. And tell me what you have. You are going to master gradually the principles of coding, but you see, you're not just writing code here. You are first of all understanding the financial ramifications before you write the code. Like, you got to solve the thing in your mind, understand it in your mind before you actually work it out. Okay, who's ready? Who's done? It's easy when you see the results, and then knowing that you can see the results, then you can actually do it. Nobody is done yet?
I'm done, but I'm having a challenge printing the results in West.
Okay, you forget about that one. Okay, the challenge you're having is possibly because there is no space. You have closed this thing with a spacing. You're supposed to bring a space here or that. Or it's just a matter of copying this and pasting. But if you can't, just use the same old approach. Use the print, blah, 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 round everything, and just use the old approach and show your result.
Okay. I had
Linda,
10,000.
are you there?
Yes, sir, I'm here.
I'm not feeling you. Richmond,
Yes, sir.
tell me what you have.
Please, I had 10,174.67.
Okay. Who else? Who else? Suppose I don't believe what he had. All right, so when you do that, you're going to realize that the investment is worth $100 in today, basically.
Yes.
Another
Doc, I also had $100
It's a warrant.
into.
It's a warrant.
Oh, Doc, I did though.
It's a warrant. You're going to realize that the investment is just worth $100, nothing more. Because the future value was given to you already here. So all you got to do is to drop in that future value. All these other ones, we've spoken about them already. We've spoken about everything already. Investment is just worth $100. So it means that If you put in $100, okay, if you start making regular payments of $100 every month, and you do one time $100, but every other time you are adding $100 every month for the next 10 years. By that 10 years time, you're going to get $15,692.97. That's what you're going to get. So all you got to do is to put in $100 today, and every other month you add $100, and then you're going to be worth that amount.
Please, Doc.
Yep.
Okay, so I inserted, I made it the MPER. I wrote the 36. That's the.
You wrote what?
Okay, so please, it's okay. I've seen it.
Once you've been able to detect your error, that's okay. The most important thing is getting it. But I want you to also understand the interpretation of your result. So part of the reason why a lot of people are not wealthy is because they don't see the power of compounding, especially monthly compounding like this. The person every month, the person will consume $100 easily. He can go to a restaurant and all of that. Every month you consume $100. But if he's putting that $100 down each month, some people will spend a lot of money on their internet, on their DSTV, on their Netflix, on their Disney, on their several things, okay, which is worth more than $100. Now, if they should put it down and put it down, put it down, that's it. Within a couple of years, they would have made an income of that. So that is how. So this is a compounding principle, but it's a monthly compounding. The whole point is save $100 every month for 10 years at an interest rate of 5%. And you will get $15,692 in 10 years' time, period. Let's go to example 3. Again, it's getting a little bit complex. We are building the complexity, okay? Yeah, let's start with this example. You also have that. So these are two scenarios here. First, compute the present value of an investment that will give you $10,000 15 years from now at an interest rate of 3% per year. Okay, let me just edit that. I don't know why I keep writing. At an interest rate of 3% per year, okay, and assign it to investment 3, okay, because we are doing a third example. So that's the first one. Then another one with a time horizon of only 10 years with an interest rate of 5%. So you are doing two of them very quickly. So just run that very, very quickly. I just want to know the answer. You just copy and paste for each one of them and tell me. Let's call the second one investment 4 and this one investment 3. But you forget about the assignment. You can just use that word and assign it. Let me just remove that part. That naming it, and you can just you can call it PV3, and then the other one call it like PV4. Okay. So what answer do you get for the first one? The only difference between this is that one is having an interest rate of 3%, the other is having an interest rate of 5%. And also the number of period for the first one is 15 years, and then the second one is 10 years. Every other thing remains the same. Now remember, in future, both of them, you're going to get $10,000. How much should you put in now? The one that is going to take long, 15 years, and you will get 10,000. How much should you put in now? And remember, there are no other payment, no monthly payment or yearly payment. How much do you put in now? In today's dollars.
So, Doc, for the first one in today's dollars, I am getting 6,418.62.
And then?
I'm working on the second one now.
Okay, what about Seth? Seth, I'm not failing you at all. It's not healthy. What about Linda?
Yeah, I'm with you. I'm with you,
Yes,
Pan.
sir.
Yeah.
Don't use the word pan. You're already penalized. You don't know yet.
No, sir. But sir, I've been talking, sir.
So what is the answer for this?
Yeah, sir. I was actually finding my way around the number two. I have the answer though.
Tell me number one.
So we've done 1, 2, and say we're on number 3 now. I'm a bit.
Oh, yeah. I'm talking about the number 3, the first part. So you mean you are behind what we have done? That's
No,
what
sir. I'm also on the number 3, sir.
So why do you have to say that I'm done with number 2? Because we've done already finished with that.
Yeah.
That's what I'm talking about. Yes, Linda, what did you get?
So I had with number 3, the first one, I had 6,418
Point what?
0.62.
And then the next one.
I had 6,139.13.
Perfect. All right, good. At least you got somebody who has done both. Let's move on. Okay. The rest of you are getting the point now. So that's the most important thing. The most important thing is you are getting the point. Now let's go to, so when you check both of them, okay, and you run them, I've not run it, but when you run them, you're going to get these answers. 6,400 and then 6,100. Okay. Let's go to example 4 and example 5. Example 4 and example 5. Now here, it's tricky because the first one says, what is the future value of $10,000 investment held for 5 years in a savings account with a 10% simple interest paid annually? Now remember, it is a simple interest paid annually. And then what is the future value of that same $10,000 investment held for that same 5 years in a savings account with the same 10%, not a simple interest paid annually, but a compound interest paid annually. So do for the simple interest one, and then do for the compound interest one. Now, the difference between the simple interest and the compound interest will be revealed in these two questions. Now, the compound interest is very easy because we've been doing it. The simple interest is also very easy. The only thing is that we've not done it yet. So that's why I've given you the formula on how to do that. What will you get? You should be able to use 2 minutes to do each one of these things all the time. 2 minutes. 2 minutes every time. 2 minutes. You can use the old approach to calculate for both of them, but I thought the formula here is simple to calculate the simple interest. Who is done? Remember, coding requires you to be fast. So first of all, let me ask before you even, which one is going to give you more money in 5 years?
Doc, I think the one with
The one with the what?
the compound interest.
Why?
Because
How is
every
that
year,
different? How is that different in simple language? How is that different from the simple interest one?
with the compound interest, every year, the profit is your main capital plus the profit is calculated every year. The interest is calculated on the amount, like the first year, after the first year, the following year, the interest is not only calculated on the principal, like your initial value, but it's calculated on both the interest accumulated and your principal. So it will be a little bit higher.
Okay. So how do you think the simple interest is then calculated? The way you've explained the compound. In simple language.
Okay, so with the simple interest is normally calculated on your principal every year, principal without any interest attached to it. So maybe the first year, if it's 10%, that's 10% every year on the amount you invested, the initial amount you invested.
And then the subsequent years, whatever you had was not added to the one you already had.
Yes, sir.
Having that understanding is important. So why do you think a person would then go for simple interest? If compound interest is good, why do you think a person will go for simple interest? What will necessitate? What will necessitate a person to say that, oh, this time I'm going to go for simple interest and not compound interest? Is the question clear? Robin, are you here?
So
It's like you are lost completely throughout, isn't it?
with the coding, not really, but just I didn't get like that explanation well. So
You mean you didn't understand the
I'm
explanation?
not sure.
Are you saying you
Sorry?
didn't understand the explanation Linda gave?
Yes, please. Yes, please.
But you should have asked her here. But you didn't ask her. Now that I'm asking you, you're now saying that she didn't help you. So I want you to ask her. Ask her now.
Linda, can you please explain what you explained it again? Yes, one.
Okay. So Doc was asking the difference between the simple interest and the compound interest. And I was saying that with the compound interest, after the first year, the interest is calculated on the initial value you have plus the interest you accumulated from the previous years. But with the simple interest, it's only calculated on the amount you only invested. So any interest you accumulate is the next interest is not calculated. It's only calculated on the principal you just initially invested. Please, do you get it?
Yes, please. Yes,
If
please.
you say yes, please, I'll tell you to explain. So don't
Yeah,
just
I get it now.
okay. So now my question is that what then is the advantage of the simple interest?
Hmm. I know that one they are doing. I'm not sure because if I got here correctly, the compound it means every year that the interest is being calculated on the principal plus the interest, right?
Yes.
Yes, but the simple is just being done on the principal.
Yes.
So you have not answered my question, right?
Yes. I'm not sure.
Because
Sorry, I'm not sure.
your understanding is more important than just a calculation. Guys, you're not just using machine learning, to calculate without explaining. You got to first have an understanding before you use. Else your calculation is useless. You can't interpret it to anybody. Okay. When is a simple interest equal to the compound interest?
Doc, I think in the first year.
You are very good. You are very smart. Your heart is here and your mind is also here. That is correct. So it's only in the first year that they are the same. Okay, what are your answers? Those of you who were not talking, I'm sure you were calculating. That's why you were not talking, right?
Doc, I had the same thing.
Same thing of what? Nobody has mentioned the answer.
Okay, I went off, so I don't know. Okay, you have moved to the next example. Sorry.
Okay, Doc, let me talk some, Doc. I had 15,000 for the simple interest and 16,105 for the compound interest.
That is correct. So if you guys should work it correctly, you should have these results, okay? The simple interest will give you this, 15,000, as you can see down here. And then the compound interest will give you 16,105.10006. So the compound interest gives you more money in 5 years than the simple interest. But if it is just 1 year, and guys, you can change it here. Just go to 1 year. Change this one to 1. Change this one to 1. Let's run it. Linda, you can see your answer now. You see your answer, Linda. So, is Linda here?
Yes, sir.
You see your
My
answer. So that's your answer. When the interest rate is the same, or when the year is 1 year, there's no difference between the simple and the compound interest. But if it is 5 years like this, they differ. In fact, the more years there are, let's say it's 10 years, the more the compound interest is way better than the simple interest. You can see that in 10 years, the compound interest is more than 5,000 times, almost 6,000 times more profit than the simple. So, why would a person want to do simple interest? Well, if your goal is just for a year, then you go for that. Okay, any questions so far? So when I give you different ones and tell you to solve it within a period of 5 minutes, you have some of these tests. I'll set it up. The moment you click start, the time will go. And within 5 minutes, the time will stop automatically. And I'll use this test as a way, and you have to write your code in R, in Python for me. Okay. Now, in your slide, let me show you here in your slides. In your slides, you are supposed to attempt some of these on your own. Please confirm if you can see my slide.
Yes, please.
Good. So you have a couple of them for you to attempt in Python, work it out on your own, come out with some lovely results. Your friend tells you that he will sell his laptop for 3,000 Ghana cedis in 2 years' time, but wants to use it for a while. You decide to buy at a price in 2 years. how much money should you set aside today in order to pay for the laptop if you can earn 8% interest on your money? So work it out. Now let's go to present value and future value of multiple cash flows. Everything we have been doing is more or less single cash flows. Most of what we've been doing is single cash flow. Now let's work out with present values and future value scenarios with multiple cash flows. Multiple cash flows here means you're not looking at a single, cash flow. Now you can create pandas data frames and assign variables to them, and then use the formula to do the right thing. So let's say that we want to calculate the present value of multiple cash flows. We have to discount each of the cash flow, the future cash flows, or what you might call the future value. Each of them, because there are multiple of them. To discount each of them back to today's terms using the discount rate. Remember that the discount rate time T can also be equal to I in some formula. So this is the actual formula for the present value of multiple cash flows. Actually, if you look at it without the summation symbol, here, everything is as it is before. Okay, so this would have been the future value divided by, but the T here means that we now have a certain number of cash flows, and that is, multiple cash flows that are working out here. The CFT is the cash flows in period T, R is the discount rate, N is the number of periods, as we know. The summation means let's put it all together after calculating. Let's take an example. Okay. So assuming a cash flow of, I want somebody to read this and let me see. Abra, read it. Read what's on your screen, Abna.
Okay. Assuming a cash flow of 30,000 cedis, 40,000 cedis, and 50,000 cedis over a 3-year period, with each amount occurring at the end of each year. What is the present value given an interest rate of 25%?
Good. What is the present value? And I think you guys also have it. Okay. So how would you have calculated what the present value of these stream of cash flows are? You have the question with you. How would you go about it? Now, one way you would have probably decided to go around it is you're going to do it one by one, isn't it? So you calculate this, you calculate that, you calculate that. So one thing somebody might say, let's do is, okay, the person might say that, let me take the 30,000, and then you have the present value, the interest rate is 25%, so it's 0.25%. There are two ways, of course, you can calculate this. You have the interest rate of 25%, you have the period of 3 years. Okay. And for each one, you don't have a payment, a regular payment. And so I'm going to calculate for 30,000, calculate for 40,000, calculate for 50,000, and then I'll sum up. That is cool. And that is okay. But there is another way you can do that. In Python, you don't need to do it one by one. So how would you go around this? So let me show you. One way you can handle this is you can write the cash flows. Okay, so let me show what I mean. You can write the cash flow. So I want you to follow me whilst I do this. I want to do the easier one first before the difficult one I show you. So you're going to write cash flows. So in your command, write cash flows, cash underscore flows equal to, are you doing it with me?
Yes, please.
Yes.
Because I want you to, because you don't have the answer. Then you do equal to, then square bracket, and then inside the square bracket, you're going to write the amount. Remember, the amounts are all down here. Okay. 30,000, 40,000, 50,000. Remember, you're not going to bring the comma or the Ghana cedis. So that would define your cash flows. Okay. The next thing is you can say that, so you come to the next line and write R equal to 0.25. What do you think this one is? What do you think this one is?
Is it the R?
Look, that's the interest rate.
That's the interest rate, the discount rate. Very good. No question, Benobisan. Okay. So you do that, and now we are ready to calculate the present value. You're going to use a very simple coding arrangement. So you write PV, present value. Okay, let me write it here. You write PV, which is present value, equal to sum, SUM. Okay, present value equal to sum. Then you bring brackets, and then you bring square brackets, and then you write CF, small letter CF, divided by bracket 1 plus R. That is the cash flows divided by the discount rate, divided by 1 plus the discount rate. Close the bracket. Then you do exponentiation. So you do star and another star. Then bracket multiplied by I plus 1, close bracket. And now we have to define the I. Then you leave a space and write for I, comma, and continue. I have to bring it down. For I, comma, CF, that is a cash flow in enumerate. CF, which is a cash flow in enumerate. So you're going to iterate the results. Close bracket, then you write your original cash flows, which you had here, the same thing into that. You write cash flows, cash underscore flows. And after the bracket, you bring your square bracket to close it. And then you bring your final bracket to close all of it. You're done. Now you print into brackets your result. Whatever name you give to that thing, you know, you can give whatever name you give to that thing. You know, the usual way of printing your results. And remember, the name you had for it was PV. So you can use that PV, whatever name you give to it. And then you can print your result. I want you to do that and tell me your result, what errors you had, what result you had.
Look, I got 75,200.
Okay. I mean, look at your eyes, look at your brain, and tell yourself, if you're correct, you know, isn't it?
Yes, please.
Yeah, if you are correct, you know that, Doc, I'm correct. Or you say, oh, Doc, I think I'm somewhere on the moon. I'm clearing everything and showing you the results. Who else had something? Is he the only one who was following me?
I was following, but they said invalid syntax.
Yeah, so you had some typos.
Doc, I also has 75,200.
Yes. Okay. So we have some people who are getting some 75,200. That's the answer, which is correct. See, if you follow my approach, you get simple, easy result. Now, what is happening here is that you see, you also have to understand the coding. So this star here is raising the whole thing to the power. So anytime you have this, it means that everything on the right of it is a power form. Okay. So you are raising the thing to the power form. And so what you are telling is that you are summing the cash flows and you wanted to kind of iterate the whole process so that the whole process becomes easily iterated. And that makes it really, really easy to put in. So if you have another cash flow for the next time, and you fit it into the formula, it will take care of the rest. If you have another cash flow, you fit it into the formula, it will take care of the rest. That is how it is. It's a very simple way. There is a complex one, which I've done here too. The good thing about a complex one is that I'm using the pandas, so you can put everything into a table. So when you run this like this, you get a cash flow, and then for each cash flow, you have the present value, the one you would have normally done and added. So you have the present value, 24,000, 25,600, 25,600, and then you add all, and that will give you 75,200. But that one is a bit long, but this one is a bit easy. Okay, so this is what I want you to do to fill in the gap that you have for that answer. Now, I want you to watch something. Watch this. You had a cash flow of 30,000, 40,000, and 50,000. Okay, so the next question is, what is the present value given the interest rate has gone up? Remember, the interest rate was 25%. Now the interest rate has gone to 30%. Quickly tell me what will happen. You can go and change your answer and then tell me quickly. Yeah. Who can quickly change the answer and tell me?
Doc, please, it's 69,503.87.
Good. That is thinking. Okay. So when you do that, you're going to get something like this. 69,503. Okay. That's what you get. So what has happened to the present value of this multiple cash flow? What has happened with the rising interest rate? What has happened?
The present value.
It has what? It
has reduced. It has reduced.
So as the interest rate is going up, the present value is coming down. Okay.
Right.
The present value is coming down. Now look at the next one. What is the present value if the interest rate comes down to 20%? What do you get?
$81,712.
Are you the only one calculating the thing? Look at the other side.
96.
Doc, 81,712.
You are repeating or you've also worked it?
Doctor, I worked it out.
Okay. I just want to be sure that everybody is participating, guys. That's all. All right. So again, what will you conclude?
The conclusion is that as the interest rate reduces, the present value increases.
Good. Good. So it means that increasing the interest rate, and you want to write that conclusion there. Okay. So you can see that once again, it comes to 81,000. If we change it to 15, and then you change it to 5, you will see that increasing the interest rate, and you want to put that point down, and I think I had it for you guys. Increasing the interest rate will increase the future value, and decreasing the interest rate will reduce the future value. So that's one principle about multiple cash flows. Multiple cash flows. Any question on this before we go to the next one? Good. Now, we've done present and future value of a single cash flows. Let me take you to the note. And then we've done a present and future value of multiple cash flows. So what is the whole importance of this to a financial analyst or someone who wants to understand finance? What is the essence of all these? Well, there are some importance of time value of money in all of this before we go into the other nitty-gritties for later. The first point is this. Let's say you want to establish a business. A good business will generate income every year, but it will usually need an upfront investment, what we call capital. You can determine whether the business is worth starting today by calculating the present value of the income you will get tomorrow from that income, and then compare that income to the cost of the investment. You can calculate that. You can calculate the present value of a future investment. Well, if you have not done in business, you might not fully understand, but the business people, they always want to know this. Most business people want to know this before they even put in their money into that. Somebody say, if I put in this money, how much will I get? The mistake they are making is that it's not how much will I get. How much will I get against what I have put in and the time I will spend? So you're not just matching what you will get, but you're matching what you will get against what you will get relative to what you have put in and the time involved. Let's take another example. You want to pursue a master's degree. We know that when you pursue a master's degree, it will increase your salary over time than sticking to your undergraduate degree. You can determine if it is financially viable by comparing the tuition cost. How much is your tuition cost? You guys, how much are you paying?
For the whole program, I think it's
11,500, but the whole program is about 23,000.
Oh, that's cheaper, isn't it?
Hey, Doc.
Oh, seriously? That is really cool. It's really cool. Because you know the value. Don't you know the value? Or you think it's of no value? Well, if you think it's of no value, go and determine the financial viability of this tuition cost. Compare that with the present value of the increase in your future earnings. And you will know whether it was worth. If you've probably done that indirectly, that is why you are doing the course in the first place. Isn't it? Else some of you will not do. Linda, why don't you remain your undergraduate and go and teach mathematics department? Will they accept you?
No.
When you're doing the TA, how much are you getting?
We're paid 700 cedis,
You
national
see,
service.
that's NAPCO. It's called NAPCO. Say NAPCO.
NAPCO.
Yes. You are taking NAPCO 700. You think that by the time you finish your master's degree, you think that's the money you're going to get?
No, sir.
Yeah. There is a present value of your increase in your future earnings. If you can calculate, you can tell somebody to know the financial viability of anything he's doing. That is what people pay in hours. Another thing, you can assess the valuation of an asset. You can determine if a financial asset, a stock, a bond, a treasury bill, is worth buying. by comparing the current price, the value, to the present value of the promised payment, what it will pay you. Not just the payment. For example, let's say that you're buying the thing today and you're paying 1,000, but in a particular time, let's say in 5 years, you're going to get 10,000. We don't say, oh, 10,000 is more than 1,000. No. Take that 10,000, bring that 10,000 to today's terms. So you calculate the present value of that 10,000 today. Then you will know whether it's worth it buying the assets. Time value of money is very practical. And these are some of the practical aspects of time value. So that is where we are going to end today. Next time, we are going to look at a broader aspect of the time value of money. We're going to look at something that is known as annuity and perpetuity. Say it, all of you. Annuity.
And perpetuity.
Good.
And
We're going to look at annuity. The other one who was saying, he said, what did you say? Annuity. What is annuity? We're going to look at loan amortizations. You know, like this is the interesting part, okay? Where people rent mortgages. Which one should you go for? Should you go for a rent? Should you build a house? Or you should rent a house? Should you buy a car? Or you should not buy a car? How do you handle your pension? How much should you put in so that by the time you are 65 years, you are a millionaire? We'll look at ordinary annuity, we'll look at annuity due, and then we'll practicalize that to perpetuity. We'll look at loan amortizations. Okay, calculate and understand all of this. We'll even look at some of these complex ones, which is continuously compounded annuity. We'll understand all of that. And then we'll see how to do all of this in Excel. How to bring it from Excel to here, and then we see that using Python is even more powerful than all of that. Then we'll finally conclude this whole time value of money by looking at capital budgeting, how to identify investment opportunities, how to evaluate the cash flows, how to use the net present value, the internal rate of return, the modified internal rate of return, the payback period, the profitability index, how to perform risk analysis using the Python programming, how to decide on an investment, and how to monitor and review. So that is it. Before we will now look at the real machine learning models and deep learning models. All of that. Guys, I'm just giving you a warm-up of what lies ahead. That brings us to the end of the entire